All right, last problem, and I've already started my diagram there, but we've got this, this ball being shot directly upwards with some initial speed, and the construction elevator begins to move upward from the ground with some constant speed, blah, blah, blah. So we want to find first what maximum height does the ball reach relative to the ground, and then what maximum height does the ball reach relative to the floor of the elevator cab. So the elevator cab's velocity, I'm going to call that velocity of the elevator with respect to the ground equals VC. That's what they called VC, so that's a constant. It's a constant. It doesn't change. Velocity of the ball with respect to the ground is going to be, well, initially it's going to be V naught, but then it's going to change by GT every time, right? So, or by GT, with the time T, it's going to change by negative G times T. So this is just your standard velocity over time equation for projectile motion. Okay, so incidentally, positive y this way. Always draw your axes and etc. and let us know what you're doing. Okay, so first thing we want to find is maximum y of the ball with respect to the ground, and that's when velocity of ball with respect to the ground equals 0. So that means that, actually we don't want to narrow there, equals v0 minus gt is that, and then t equals v naught over g, and at that point, so ybg equals vbg times t minus 1/2 g t squared, and we use this t. So, I'm sorry. So actually this here, I'm going to get the eraser here, but this here should be, this is the initial velocity of the ball with respect to the ground, which is, you guessed it, just v naught. So I'm going to use that, and then ybg, right, we plug this in, so ybg at max is v naught times v naught over g, so v naught squared over g minus 1/2 g times v naught over g, square all this, and then so ybg max is going to be v naught squared over 2g. Okay, well there we go. That's an easy one. Okay, and then what did we want to find here? So what maximum height does the ball reach relative to the floor of the elevator cab? Well, so at that point we want to find, let me do that. Excuse me. Woo! We got to find when the velocity of the ball relative to the elevator equals 0. Well, now we've got elevator with respect to ground, ball with respect to ground. We want to find ball with respect to elevator. So let's remember the rule for when we can smash some stuff together. It looks like BE and EG are the ones we can add together. So velocity ball elevator plus velocity elevator ground equals velocity ball ground. So there we go. Now we can smash these two together, right? That all makes sense. So this all works. So velocity of ball with respect to elevator, we want to be 0. I'm just going to plug stuff in here. Velocity of the elevator with respect to ground. Oh, sorry. Whoops. Not equals. Plus velocity of elevator with respect to ground, which is VC. I want to equal v naught minus gt. So this is not very hard then. So then this comes up here, and we do this. T equals vc minus v naught over, well, it'll have to be over negative g. So really, t equals v naught minus vc over g. Okay, that's the, what are we looking for here? I guess that's not quite what we want there. So let me just undo that boxing there. And let's see, what maximum height does the ball reach relative for the elevator cab? Okay, so now we've got to find, we do the same thing except for y. So we want to find y for the ball with respect to the elevator cab at this time. Plus, so what's y of the elevator with respect to ground? Well, I'm just going to write it out first, equals y of the ball with respect to the ground. So y of the ball with respect to the ground, so let's see, y for the ball with respect to the elevator is what we want to find out. Okay, plus y for the elevator with respect to the ground, well, it starts from the ground at 0, right, and then goes up. So that's going to just be vc, this constant speed which is going up, times t. I mean, that's pretty easy, right? Constant speed for the elevator starts at 0, so y elevator with respect to ground is just vc times t. Okay, and then v, or ybg, is going to be vbg, right. So there we go. Yeah, so it's this thing here. So equals v naught times t minus 1/2 gt squared. Okay, so we use this t here. So ybe equals vc times v naught minus vc over g. Let me scroll down just a little bit and get some more space. Okay, so that's this bit. Oh, wait a minute. Actually, whoops. Let's see, erase. Yay. There we go. All right. So we got a plus sign here. Not right there. Good enough. All right. Okay, and that equals v naught times v naught minus vc over g. And then minus, I'm just going to make this a g over 2 to save some space because we're going to be kind of cramped here. And then t squared, so v naught minus vc squared over g squared. Ooh boy. Okay, so y ball with respect to elevator. Okay. Boy, how do I want to do this? So plus, I'm just going to go ahead and expand this. So vc v naught minus vc squared over g equals v naught squared minus vc v naught over g. Okay, minus boy g. Okay, so this is going to be over 2g v naught squared minus 2 v naught vc plus vc squared over and this was the 2g. There we go. Okay, now let's see, this was a g, not a 2. I don't know where that came from. So my god, wow, this is fugly. All right, so let's just go ahead and gather all this crap up. YBE, which is what we want to find, is so v naught squared minus vc v naught, and then we're going to bring this crap over, also minus vc v naught plus vc squared, and apparently I have some, oh yeah, somebody asking me for answers to the WebAssign, I think, which is what I'm working on, so almost there, please. Okay, minus v naught squared minus, well, I'll tell you, I'm going to square plus vc squared over 2g, and then I'm going to take this bit out, minus minus, so plus v naught vc over g. Geez, oh Petey. So needless to say, you could have done this a lot faster, you know, just non-symbolically. So score 1 for you guys. So this is plus v naught vc over g, and this is minus 2 times v naught vc v naught over g. So ybe equals, and so let's see, v naught, wow, okay. So this is going to be v naught squared. So we got a v naught squared over g minus v naught squared over 2g. So v naught squared over 2g. And then we've got vc squared over g minus a vc squared over 2g. So minus vc squared over 2g. Okay, and then minus 2 vc v naught over g plus vc v naught over g. So minus vc v naught over g. And wow, okay, so wait, this should be a plus, my bad. And then, so we can actually multiply this by 2 and 2, and then, geez, y for the ball with respect to elevator. This is going to turn out to be way neater. Okay, so this is actually going to be v naught squared minus 2 vc v naught. So v naught minus vc squared over 2g. That's the maximum y, and this is actually almost forehead slappingly obvious because really this is just the initial velocity of the ball with respect to the elevator squared over 2g. I mean, this is the standard formula for how high something goes if you throw it up at some speed, applied to with that speed being v naught minus vc. So we could have just said at the beginning the elevator starts rising constantly, so and the ball gets thrown up. Yeah, wow, we could have done this much more easily. But there you go. There's your answer, and you just plug in the numbers you get. So let's see. I'm going to just go and do this. Maximum height relative to the ground was v naught squared over 2g. So let's see, v naught squared. So 40. Come on. 49 divided by 2 divided by 9.8 equals blah blah blah. So that's going to be 2.5 meters. Maximum height relative to the floor of the elevator cab. 7.0 minus. So 7.0 minus 3.2 is going to be 3.8 x squared divided by 2 divided by 9.8 equals, let's see, 0.737 apparently. Well, all right, let's see. 0.737. I'm just going to punch those in and see what I get. Yes. And then at what rate does the speed of the ball change relative to the ground? Sign and magnitude. Why? That would be negative 9.8, right? Yeah, because that's just acceleration relative to the ground. At what rate does the speed of the ball change relative to the cab floor? Well, the cab is not accelerating, so it's actually also going to see the same acceleration. So let's see. And yes, there we go. Correct. Fantastic. Done with WebAssign. I will post this, and good luck on the test.